Right, gentlemen, you're very welcome to this session of the Heritage Society of Engineers Ireland. And this evening, very glad to welcome some members of the Civil Division and also the Transport Society. And of course, a particular welcome to any visitors as well. I should start that again by probably saying ladies and gentlemen, because we have a couple of ladies joining us. First of all, just draw your attention to the emergency exit facilities, which are relatively straightforward, either the way you came in or the emergency door on the right-hand side of the lecture theatre. And if you wouldn't mind just checking that you've put your mobile phones or any other electronic devices to silent or to flight mode or whatever it is you do with them, I'd be very grateful. Our speaker this evening, Michael Phillips, is of course known to many of you. He is a chartered engineer, a fellow of Engineers Ireland, of course, and of the Irish Academy of Engineering, and also a fellow of the Institution of Civil Engineers across the water. And of course, recently, I think 2013, he was president of Engineers Ireland. Now, until recently, he was Dublin City Engineer and Director of Traffic, with responsibility for all engineering infrastructure and services. Projects which he was there to look after included the Dublin Port Tunnel and the Ringsend wastewater treatment works, two very, very large projects, civil engineering projects in terms of the size of projects in Ireland. This year marks the bicentenary of the construction in 1816 of the Liffey Bridge, or usually called the Halfpenny Bridge, one of Dublin's best-loved landmarks, and said to have been manufactured at the famous Coalbrookdale foundry in Shropshire. This metal bridge was the first pedestrian bridge in the city, certainly the first of any size. Dubliners had to, of course, pay a halfpenny toll in order to cross the bridge, giving it its more commonly used name. So Michael will tell us the story of the bridge, its manufacture, restoration, and its place in Dublin's history. So it now gives me great pleasure to invite Michael to present his lecture. Michael.
Thank you very much, Ron. Good evening, ladies and gentlemen, and thank you very much for this invitation to give this paper. A lot of the information from this paper actually is sourced from, there was a more technical paper given in 2012 by Patrick Gorman, who was a senior executive engineer in the City Council, and so there's a good reference point there. And it's one of the things that when you work on a bridge like the Halfpenny Bridge, which requires conservation, that you really need somebody who has a love for conservation, takes a real personal interest in it, because from the time, as any of you have worked on such a project, from the minute you actually peel off the first cover, nothing is as it appears. You know, and you need somebody who makes decisions, who appreciates the importance of it, who appreciates the aesthetics, the conservation, and most importantly today, the safety aspects of a thing. So, and Patrick Gorman was one of those engineers that had brought everybody on board, and Bruce Arnold was there as a conservation architect, and we had a very good people who were really dedicated to it at the time. And it's just I'm just very fortunate. I was to be the city engineer at the time, and to have people on your staff who can do that type of thing. But as you can see from that picture, I've quite a few slides, so I'll flick through them as quickly as I can. But just to give you an indication of the issues and the problems that are there, that's why we'll put the pictures up. But you can see from there, it is very central in the centre of Dublin. It was how Dublin was recognised. It's not a suspension bridge, it's not a cable stay bridge, but it's how it's recognised. And okay, the Samuel Beckett, I suppose, is the modern day one that people will recognise, but this is really I suppose the jewel in the crown at the time for the bridges. But I'll take you through it as you do. But just to give you an idea, you've got to show where does it sit and how it works. And look at there is you can see the Halfpenny Bridge is up on the just here on the right hand side, but it gives you an idea where the bridge was when the Vikings came in. And this is the blue pool, and you can see the grid actually in the quay wall here if you stand on the Millennium Bridge and that. But this was the ford that would have been, everybody would have been recognised around the year 1000. But what that ford also is where the people could cross the river at low tide. Everything below that, even at low tide, with only at exceptional low tides, could you cross at another ford here at that. So it gives you an idea then that when you start moving down river here, you're really moving into the deep water side. This gives you an idea of the ford that would have been there in the year 1000. When we were doing publication on the both for the website and for the bridges over the Liffey, we got sort of an archaeologist historian to actually do, because they talk about the cattle being brought across and everything like that. So what would a ford have looked like? Now that was in the year 1000 AD, but to give you an idea, you had the Pont de Gard there in 91 BC, and you had the Angie Bridge in 605 AD. And this bridge here, it gives you an idea of the span, but also the idea of the principle of the weight being taken off the abutments, you know, with the arches here as well. So it gives you an idea that technology in other countries, or the development or evolution of things was way ahead of us in Ireland at that time, which is a bit surprising when you consider of the monks going backwards and forwards, that it hadn't come back with them, so it didn't. But when you have a river, you have there's, I suppose it starts with that you have a ford, and then when you don't have a ford but where you have water, you have ferries. But the thing about particularly and fords is the loss of life that actually occurs, because people will try to cross them without. We see it even with the floods, that people will think the river is safe to cross, and it's not safe to cross, and boats will overturn, and we see that particularly maybe in other countries today. So when you build a bridge, actually the number of fatalities goes to zero, and that's one reason why bridges have a quite a strong affiliation with the general public, not just with engineers. I give a talk on bridges and over the Liffey in various libraries, and there's never less than 50 people, you know, and some nights it would go to 70 or 80. And one night, in actual fact, it was a ladies' historical society had actually asked me, and there was 70 of them there. So it gives you an idea. So when I was talking to a person who's building bridges in Africa there about 2 years ago, I was talking about this idea again of the village and the people with the bridges. And what she said was, she was an engineer working in Uganda, and she said, actually, Michael, it's not the elimination of fatalities that makes bridges so important to a local community. It's the elimination of fear. And I had never appreciated, really. She said, it's the fear of the children going to school, and will they make it home? It's the fear of your partner going to the market with the vegetables, will they make it back? Because in the intervening hours, the river could have changed its characteristics and be in flood or whatever it is, this worry. And she said, that's really what you begin to realise. They will tell you, it's the elimination of this fear. And this is part of what actually happens here in Dublin. Actually eliminated the ferries with the building of the bridges. And the Halfpenny Bridge, which you see here, is just one of those areas where the thing. But where you see the numbers 1, 2, 3, and 4 gives you an idea of where the bridges were built in the period about 1650 to 1685. The Duke of Ormond was there, and he built 4 bridges in that period of time. So he did, so again, people were staying away, or the technology wasn't there to build further downriver, so it wasn't. This then gives you an idea of the populations, that how the population of Dublin and all that varied, you know, and you can see the Black Plague, you can see Cromwell. And then you can see from 1700, the population suddenly starts escalating. Even though in 1730 we had one of the worst winters ever, and I think over 500,000 people died here in the country over that winter. Because that was the one that you will read about in the books of where they had barbecues on the River Liffey. It was frozen over. But what actually happened was, they think there was an explosion or a volcano in the Pacific which stopped the winter, the following summer coming in here, which meant that all the potato crops failed in the ground as well, and lots of people died or were frozen to death. But it gives you an idea of the demands that were going on. Now, the Halfpenny Bridge was built in 1816, but you already had Carlisle Bridge, which became O'Connell Bridge, built in 1794. So it gives you an idea that they had already built this bridge downriver, the use of caissons. The first use of caissons actually had come in with the Capel Street Bridge, as you would know it, or Grattan Bridge, as we would know it, was a man by the name of Semple. So the principle was just established in about 1753. 1794 then came O'Connell Bridge, and that was with the building of the Custom House and the moving of the city centre from Capel Street to O'Connell Street. You began to see a moving eastwards. But this is just to give you an idea of the other two bridges, two main bridges really, that would have been built around the same time. The Rodeo Moor Bridge, which is an absolutely beautiful bridge, it was built in St Helens in Lancashire and floated into place in 1863. It replaced a stone bridge there. And then you had Houston Bridge, which was a new one at the time, but that was built just above, that was actually cast in where Hickey's fabric place there is. There was an iron foundry there, and it was cast there and just lifted out into the river, so it was. But then the bridge, the Hipney Bridge was actually, we've no documentary proof, but everything totally indicates that it was fabricated in Coalbrookdale. And Coalbrookdale is a place in Shropshire in England. And Abraham Darby was the third, was the man. His great grandfather Abraham Darby the first actually set up the place. And you start to say, why did Coalbrookdale become so important? Well, the first cast iron bridge that's still in use today, really recognised nearly worldwide. There was other ones, they weren't of the same nature and they didn't last. Was completed there in 1781. It had a span of about 30 metres. I'm sorry, I don't have the width just offhand. But then in 1791, 10 years later, the abutment moved. Now, the abutment moving on single arch bridges is quite a normal thing. It's because of the truss and nobody knew what was there. So you had this continuous movement. And the designer there was John Windsor. And in 1973, actually, they totally refurbished that bridge. But what they did was they put a concrete strut along the river bed to keep the abutments from moving any further, so they are coming closer together, so they did. But the main reason why Coalbrookdale as well was so important, or is so important in history, is the coke. They started to use coke there to do the smelting of the iron and stuff like that, rather than timber. Timber and all that had been there. And it was this development of coke in Coalbrookdale that really gave a real kickstart to the Industrial Revolution, because suddenly they could do large volumes. And what they started doing here was actually developing pig iron into ingots, which then could be used in other smelting places further down. But Wearmouth then, that you see down below, was the second bridge really in the UK that was done, and that was it was done in 1796. But its span, as you can see there, is over twice what Coalbrookdale was. The width was 10 metres, but it's only 75% of the weight of Coalbrookdale. So you could see how the technology had moved. And the designer was a man by the name of Thomas Wilson. And he'll just become important in a few minutes, so he will. But that gives you an idea. Now, just again to show how history operates. Part of the Sunderland Bridge is made up of a bridge that was done as a pilot scheme. It was built on dry land. A man by the name of Thomas Paine, who, if anybody here knows anything about the writing of the American Constitution, was involved in that. He was a philosopher guy. And this is one of these inventors that believed, he didn't believe in the aristocracy in the UK, and he actually went to America, and he was very friendly with Benjamin Franklin, Thomas Jefferson and George Washington. And he was involved in the writing of the American Constitution. And everything was meritocracy rather than aristocracy with him, and this was the way it was. And that's the way the American system was built. He then came back to England, and he got involved in, he saw this idea of bridges, and he got very involved in that and did the designs. And he did a design for over the bridge, River Seine, and he did a couple for England. Nobody would actually buy his idea. He had this a design done for a 400-foot arch to actually be done. So he built a pilot one of 100 foot in a place called Walker's Iron Foundry in Yorkshire. And Thomas Paine then went, whether any of you know, his life story just says something. He went to Paris during the Revolution. He was locked up in jail and was supposed to be guillotined, but he got away with it. And he then went back to the States, and he actually realized when he got back to the States after 15 years that the system that about democracy is money means everything, and I think we can see that today when we look at maybe the American system. But it's quite a fascinating his time. But part of Paine's bridge was actually used in the Wearmouth Bridge, and Thomas Wilson did an awful lot of bridges out of the Walker thing. So then when you begin to look at Dublin, how did the ferries come? They became, the city council had a charter from Charles II, and they let out the ferries. You just couldn't set up a ferry. That was known as the one at the Hipney Bridge is known as the Bagenio one. And that refers actually, they reckon, to a brothel that was actually on the south side, just where that ferry came ashore, and that's how it got its nickname, like everything in Ireland. Then the Halfpenny Bridge is also located in the tidal zone, as I said, and Essex and Carlisle were completed earlier. The span at this is about 42.8, and the width of the bridge is 3 metres, and the rise over the full span is there. But the toll was to remain at a halfpenny. When he got permission from the City Council, the toll was to remain as a halfpenny, which was the ferry charge, and also that if the citizens of Dublin didn't like it, he'd have it taken down within 6 months. Now, the two people, like everything in these countries, like nothing is really a straightforward decision. We look at the complexities of society today and how we've got to keep everybody. And back then, those complexities were there, maybe in a smaller thing, but there was a guy by the name of John Claudius Beresford, and his father before him had been a major leader, and he was unofficially the King of Ireland, but he was involved, he was an alderman, a member of the council, but he was also involved with the Port and Docks and the Revenue Board and all that. And the Lord Lieutenant at the time fired him and said he should have nothing to do because of all the dealings he got involved in. He was so powerful, actually, he had the Lord Lieutenant recalled. That's how, and he was reinstated into his job. So give you an idea of the powerful thing. But family also were related to another Beresfords in Derbyshire who founded the Butterley Iron Company. And the reason why I mention that is, and his daughter married Walker's son, who was the guy who was working with Thomas Paine. So you could see that they were involved in the Irish, in the iron industry. So he was aware of it as opposed to masonry and to that. Now what actually happened was, in 1802, 1803, the bridge just upriver as you come down from Christchurch collapsed in a storm, and the bridge designer Thomas Wilson was invited by the City Council to come over and see could he propose an alternative. Now William Walsh, the guy who had the ferry, and Beresford were on the City Council, so they would have been aware of this, and he actually put forward a single span to cover the bridge, but the City Council didn't accept it, and they went actually with the 3 arches, the stone arches that you see there today. But, and part of that problem was that Wilson had done 2 projects, one in London and one in Yorkshire, and again the abutments had moved and the one in Yorkshire had collapsed, and that had happened maybe around 1803. So maybe the City Council were following the precautionary principle and deciding to wait until maybe the designs would have had more experience. So they were. And as I say there, Thomas Paine also met a Dublin delegation in London when he was there at the time in 1789. And what we feel is maybe William Walsh and Beresford might have been on that delegation at the time. So they were. So what they then did was, this would give you an idea of the Sunderland Ware one that was there, and that was only taken down in about 1853, so it was. So they then approached Cole Brookdale. So this is how we end up then going back to Cole Brookdale, and the experience again that you had Beresford, who would have been well aware of the technology. You had William Walsh, who was the guy who had the ferry, and they went to Cole Brookdale, and Cole Brookdale came up with this single arch, which at the time, you know, was quite fantastic, because what you look at the Liffey today and you might think it's quite there, you've got to appreciate that there's 3 dams on that river, so the river is very well contained. You can imagine when the rains came down, it was quite normal for at least 1 bridge a year to collapse nearly on that river, because the arches would be eroded the ground and that. So he decided then that, so this was the bridge then that got built at the time, and you can see again hiring out space, and we've sort of gone back to that nearly again today, of the public-private partnership, so it is. And then the turnstile booths, which, you know, we have very few pictures actually of, that gives you an idea. They were there on the south side, so they were. And then while the Chairman Ron was talking about the love relationship with it, there was also a hate relationship. The bridge has gone through periods of love and hate, and what you see down there is this was the one that Hugh Lane wanted a place to actually put all his paintings, and he wanted to build a gallery. So his whole idea was take down the Halfpenny Bridge. He hated it, and build a gallery with a Ponte Vecchi like in the bridge in Florence, and put all the paintings in that. Now, there was another man that was a very strong personality at the time in Dublin in 1914, and that was Martin Murphy, who was over the, he was fighting at the time of the lockout and all that, but he said you shouldn't waste taxpayers' money on such a thing. And then Hugh Lane got worried about if there was a fire or if there was dampness and things like that. But actually, while this was all ongoing anyway, Hugh Lane happened to be on the Lusitania, which sank. And that's just, then now you have the story about whether his painting should be in London or Dublin, and what they did was they split halfway. But it gives you an idea that there was a love-hate relationship, and there was fairly powerful forces there as well. But the historical facts are, you know, that some things there which I've already repeated, as said. But one of the things is that cast iron, you know, has a low tensile strength, is brittle with no ductile range. The problem was the quality control was always a problem, and it had many names. It was called the Wellington Bridge because of 1816, the Battle of Waterloo. The Triangle Bridge. The triangle was after a sort of a nickname because, again, Beresford was involved very much in the putting down of the uprising of 1798, and one of the torture treatments was the triangle at the time, where they flogged people, and so the Dublin people tended to call it because he was associated with that. Then you had the Metal Bridge, but the proper name is the Liffey Bridge. And again, it gives you an idea there of the ellipse, and that's part of it. There's 3 cast iron ribs bolted, and it's founded on the granite. The river rock there is actually quite high, so it is on the river. So we're very, very fortunate there. But what we had then was, in 1998, we decided, what was happening was, first of all, there's no access for people who have a difficulty with walking. The sheer volume of people at that time, it was about 24,000 people a day were crossing it. Now, as you can imagine, we said 24,000 people a day, but that was really over a 14-hour day or 15-hour day, 14-hour day. It wasn't a 24-hour day. So we had serious concerns, especially where it came ashore there at Temple Bar, of the safety of people on the footpath and the volumes of traffic that were there. So we had a structural appraisal carried out because very little maintenance had been done. And what you can see there is there was no members overstressed, a fracture analysis of one crack they were unlikely to propagate, cracks mainly caused by expansion forces due to water ingress. Paint samples indicated lead paint. The original paints, they just kept painting over them at the time. And the main superstructure was considered safe, but the railings and the deck were in very poor condition. But this is just to give you an idea. Now, they call the South Quays here actually Crampton Quay, but to most of us it would be known really as Ashton Quay. And then Bachelor's Walk on the north side, and then you have Liffey Street. But when you go to do something with a bridge like that, you have an awful lot of what we call non-technical issues. First of all, it was a very confined site because of just the sheer volumes of traffic. But all the works had to be carried out from a pontoon in the river. And the navigation channel had to be kept open because boats went up and down the river, and we had to be careful. Then the impact on local business, and that was one of the major issues, because here on Liffey Street, the people felt that about 80% of their business came from people who came across the Halfpenny Bridge. And then, okay, you had the archaeological issues both on the ground and in the river. Did we need foreshore licenses? Then lead in the paint and dust issues, and then the conservation issues. Everybody took an interest in it, so it did. So what we did was we gave it we had the plan for the Bailey Bridge to be put across, a temporary bridge, but we decided we'd try it maybe without it for about 24 hours, and as you know, all hell would break loose, so it did, all hell broke loose. So we had the Bailey Bridge put together over a weekend and put it in, but it was in our plan, and we put it in. And if any of you remember that, quite a number of people wouldn't cross that Bailey Bridge because the bridge, it was perfectly safe, but it was a bouncy, and so quite a few people felt a slight bit unsafe that this bridge was bouncing because there was just such a volume of people on it. But they're, as you know, they're very, very strong, so they are. But so that was part of that. But just to give you an idea, you can see here railings, there was failures, there was pieces missing. And again here, the railings were supported off pieces they shouldn't have been supported off, and scaffold poles were used for temporary repairs. It was really in a very bad state, so it was. And so the superstructure overall, the condition was good, but we did, just looking at for dyes in the cracks, the railings, paint testing. And then in actual fact what we found was that the geometry of the original build of the bridge wasn't built the way it was meant to be built. And there was an imperfect elapse, and there was no bracing in some bays. And what we discovered was that, say, for instance, the part of the bridge over here should have been actually at the opposite side over at that end, in a couple of things like that. So, but the bridge had held up during that period of time, so it had. So this will give you an idea of some of the conditions of the heavy rust. And what you found was with this channel, say, for instance, you might say, okay, that provides strength, but what that web did, it gathered water as well for rust and things like that. So we had major issues there. So we had, and you can see a typical crack then at the bottom as well on the thing. And that just then gives, again, we couldn't actually take off those caps. We had to sort of try and work around them. But you can see where there was broken bracing, joints had to be sealed. There was moisture traps and blowholes, and then we had this very difficult to remove the ends of broken. Everything was, a lot of things were seized on it, and what we had to do was just work very carefully to actually get it. When the original survey was done, as you can imagine, again, we did a survey, and when the contractor was tendering, it was what you could see, and as you can see there, when you actually went in underneath, it was a totally different ball game, for want of a word. So the job had to be divided really into two parts. One was the pieces that you could take away and have it either refurbished or new pieces fabricated off-site, and then the piece that you had to have on-site. So in order for the piece on-site, and this was even a worry that we had to scaffold it all out and then put sheeting all around it to protect it. Now, one of the problems with a thing like that is you're putting the scaffolding and sheeting, but if strong gale force winds are coming, you then have a lateral load on your bridge, and is that going to create problems, you know? So all these things had to be taken into consideration at the time, as well by putting temporary supports in the river. These were pontoons resting on the river bed. Will it affect the flows if we actually get very heavy rains and a lot of water has to be released or extremely high tides? So you had to take all these things into consideration, do risk analysis on it, and see how it would work. Then this gives you an idea of just, you can just imagine the sheeting and the scaffolding that had to be carried out over the full length of the bridge at the time, so people could work there, but at the same time also make sure that there was no, dust being carried around or the river was being polluted at the time. So we had flexure, there was load tests carried out on all these pieces as well, so there were, and the result was a grade 200 cast iron, because how do you actually work out what the strengths were? Various 1,000 pieces were taken off site actually to for examination, testing, and then for refurbishment and for brittle hardness and those type of ideas. Here you can see where a piece was broken off this side and other parts were cracked. So there were. So the various options on how to put the railings back in and maintain your conservation and maintain you know, the importance of the bridge, and how do we actually fix them to the deck and ensure that they can actually be safe. Now the other question then that arose is actually how do you define what's a safe deck now and our railing for the crowds of people we had crossing this bridge? Because one of the worries about a pedestrian bridge, which some of you may or may not know, is that if you get a lot of people watching something on the river and they turn to look at the other side because something passes under the bridge, the loadings that actually arrive on the bridge and are affecting the railing can have severe effects of the worst situation is that the bridge would turn over, so it would. So we were very fortunate that in the 1973 refurbishment of Coalbrookdale, the people in Coalbrookdale actually had the Road Research Laboratory in the UK carry out actual crowd testing of railings to see what the rails on their bridge could take, and that actually provided us with a great sort of baseline on which to work off and how to do it. So then what we had to do was, okay, look at the infills. Everything had to be measured because nothing was really, I suppose, replicated in the place. Every item had to be done. So this then gave you an idea of where the sockets and the strengths that we had to build in, and then the ducting for electrical lighting to go in as well then afterwards. So it would. So this gives you an indication of what it was like inside, and you can actually, what you're looking at there is the finished deck as it was put into place, and the railings being erected on the thing, and the sockets been got. And what we had to do then as well was, because nothing was, I suppose, everything was a one-off, you had to make sure that you had to use the best grouts to actually do it. So we even carried out load tests in Harland and Wolff, who were the main contractor, to actually test the grouts that they would be able to achieve what we wanted, and that they could do it. So and this then the grouts been put into position, and this was the railing post, because we had to try and maintain the old railing posts as well with the new fixings. So we had, and again, chalk-fast was the stuff, and you can see the difference between the thing there before the final coat of paint on. Then we had to get these finials to actually for the deck, and in Enterprise Ireland actually were the people who carried out all the testing for us, and every piece was tested. We just didn't spare on it, because when you actually take a bridge like this asunder and put it back together again, you know nobody's going to be looking at it for a long time. So there was then, one of the things was, what do you do for cracks that appear? And it's very, very difficult to weld cast iron. Now, we did do it in one or two locations, but it's not a thing you can actually carry out throughout. So the lock process actually is a process where you actually drill holes, and then you actually put in pieces of iron into it. It's all done cold. It can be done on site, and they're like keys that are inserted into the thing, and they'll become integral nearly with the parent metal, and then they're filed down actually to do the thing. And this is what you actually have here. You can see it there, where the stitch in the vertical direction or in the horizontal one there, and this is a vertical one over here. And it's a patented system, but you can see here where it was actually fixed onto a member as well, using the system. And it worked extremely well. So it did. So it did with the thing. These were the arched in assemblies that you see across the top of the bridge. They were taken off and welded. But the problem then arose as well with the coming down to the abutments, that you can see how the deck there lifts off in the old bridge. And the old bridge originally was just a timber, and if you remember any of the other bridges that opened for the Millennium, the one in Paris and the one in London, and there was in one someplace, I think Brazil or someplace like that, they had timber decking, and of course when timber decking got wet, everybody just slipped and slid all over the place. So they had to close 3 of them. And we sort of became aware of that, say, with the Millennium Bridge, which is the one just upriver, and we had aluminium. That's why you see aluminium there. But on this one here, there was timber up to about 1970, and then felt was put on it because of the danger of slipping on it. But as you can imagine, roof felt on a bridge deck is not it's not really an acceptable solution. So, and also we wanted to make it more accessible. While we knew it'll never achieve wheelchair accessibility, we wanted to make it as acceptable as possible. So we actually took out we had templates carried out by Harland and Wolff of the whole deck to see what the structure was like. And then a whole new deck was designed using metal to actually give us the steps that you would see there today, and they were fitted in on you can see it there on a jig in Belfast. So it was. And then when they brought it to Dublin, because again of irregularities on the deck, they had to be assembled on a pontoon, and then each one adjusted for the sides, so that when it was lifted in, it was literally a one-off for each location. So it was, and that gives you an idea there then of the granite steps being put in onto these steps as you rise up onto the deck within the thing. Now, one of the other parts was as well that on the deck, on the site works, say for instance, that had to be done on site, it had all to be shot blasted, and you can see there how the shot blasting was carried out. But what we found was, because first of all the site was totally enclosed, as you can imagine, it meant everything could be contained on site and then moved off site easily. But what we found was that it wasn't enough, and what we found was there was still some salt contamination, and the graphitization was there. So we actually had to do a second dry blast to achieve a proper surface profile. And the SA 2.5 is based on, as you can see there, 85% of clean metal. You can only get SA 3 if it's the new metal, so it is. So it gives you an idea of the difficulties that were involved, and the conditions for the men working around those ribs was extremely difficult at times, you know, to actually get in, and the dust and try and get, because as you know, rust always will go into the tightest, furthest corner from and is the most difficult to get at by people working on it. So the blasting and you can see there the finishing of it, and then the painting of the works. But also in that we had Enterprise Ireland go through every single member of that to check the thickness of the painting to ensure that it was at the proper specification, and that because we felt that again we were just going to get one really good chance, and we went right back to as you saw there to the metal. But in going back to the metal, it also helped us to analyse what the colour the original paint was when it was open, and the actual original paint which you see today, our colour is white, and the main reason for white was for navigation back then as well, that boats would not hit it at night or during the day. But this again gives you a typical list. You can see there a typical list of the jobs that had to be carried out at each joint. So you know, it was like a labour of love really for an awful lot of the people working on it, to ensure that it was done right. And this gives you an idea then of the finish. That's really the steps, and here you can see these were the joints that we had terrible difficulty with in trying to get them off, and it gives you an idea. And then here you can see the finials fixed in, and then the arch over the lighting, so it is there. And this here just gives you an idea then of the granite steps. Now some of the people objected to the fact we were taking away the railings that were around where the toll booths were, but we had to make room for, you know, at the moment there's about 30,000 people crossing that bridge, and if you have 30,000 people, you have to make room for them to gain access onto the bridge and allow them to cross over. So the compromise was, yes, we would do an archaeological dig, which we did all around that area, find out where the original booths were, because the booths had been removed and covered over and we weren't too sure, and so that we would map the whole situation, and but that this would be then the compromise to make it appropriate to our time today. And that gives you an idea then of the curves that were achieved on it, so it was, and the coping stones as well then on it. So then the opening took place on the 21st of December, because again what we wanted was, we thought it would be very nice for Christmas if you can open a sort of a bridge like that, and it would also help the shopping and do all, and just create a nice atmosphere so to it there. So that gave you an idea what it was. But when you're talking about a bridge like this, like the Hickney Bridge, and this is where it became important, before we actually did the work on the Hickney Bridge, we actually had installed the Millennium Bridge. But again, when we were selecting that bridge, we had to be careful that it didn't compete with the Hickney Bridge, you know. And in actual fact, was there a way of enhancing the Hickney Bridge? And the Millennium Bridge, the design that was selected at the time, you know, definitely did that, because now people could stand on the Millennium Bridge and look at the Hickney Bridge, or you could photograph it from the middle of the river. The Millennium Bridge for us, what that did for us was it made a bridge accessible for everybody, you know, in relation to wheelchairs or anything like that. It gave it that. That's why there's no high span on it. But the Millennium Bridge, what it does is again, it's a bridge of its time. It's actually a portal frame. The bearings are actually at the river bed. The bearings are not at the deck level, so it does. But also, when you look at this bridge, you can see it's nearly three-dimensional, and that was made in Ireland, down in Carlow, so it was at the time in the year 2000, and lifted in by crane, so it was. And just actually again, and this is just what I'm trying to show is that, you know, you have to have the conservation of your existing structure, your infrastructure there, but at the same time you also have to build for your own generation. And this to me was one of these structures that we did, that went in at that time, so it did. And you know, we were really proud of the fact that this bridge could be made. When you look at those nodes, you look at the changes in direction, and it was lifted in by a crane, and the whole lot has fitted there so well, so it has. On a light side on that one, when they were bringing it up from Carlow, we asked that, you know, if there was any way that they could give the City Council credit, you know, we would appreciate it. So on the Sunday morning it was being done, I went in to have a look at it, and of course there was the main contractor's big name across it. There was the subcontractor's big name on the back of it, on the side of it, and on the back of it was a sign which says Dublin City Council apologises for any inconvenience caused. You know, so all you can do is stand there and laugh, you know, because and that, you know, but so that gives it. But the Halfpenny Bridge actually was so well received that it got a European prize for you know, the Nostra Prize for Culture, and so it was, because again of the conservation work that was done in it, and that you know, quite a number of places have looked at it and learned quite a bit about it. Because when you look at the age of that bridge in 1816, and if you stand on the quay there, you just think about your life. That was the original cast iron that went into that. What we take, if you take your knife and fork, you take the trucks, you take absolutely every metal that's there. That was the original metal that everything started with, you know, because the stainless steel, chromium, or all the nickels and the nickel, all these different mixes of steels that have come out of it, stainless steel and all that they've all originated with that bridge. So when you stand there and you look at it, that's actually what you're saying is, this is how everything has evolved. And it just puts its place really in history, a bridge of that age, so it does at the time. So that gives you an idea then of what it finished up as there, as you can see there. And the importance of it is that everybody still, you know, appreciate it. Now, we do have the problem, and this is again where we as an authority, as an engineer, had to compromise. As you know, the love locks started appearing on it then around it, and the logic there, a lot of people said, oh, get rid of all those type of things and not. And then yet you had to say no, because when a community take ownership of a bridge or any infrastructure, you know you've done your job as a local authority engineer. So you have. And that to me is the whole part of it. Okay, you don't necessarily like it, but what you have to do is say, look guys, we've got to manage this. And that's the way you do it. You take off the locks, or you just leave a few so people know where to put them. And if they do put them in the places where you want them, they're doing the minimum of damage. But it does mean that there's a connection with the bridge, there's a connection with the infrastructure. And to me, that's what's important. And you can see it on various charity days, the way they actually colour up the bridge and do that as well. But just to give you an idea as well, we have a series of publications coming out. Some of them have come out. The Bridges of Dublin, as you would be aware. Exercise of Authority is a paving board. But in the next, say, 6 months or next month, we have the Halfpenny Bridge by Michael English, producing a publication on the bridge itself. The River's Daughter and Poddle by Don McEntee and Michael Corkin published. We have the Rivers of Dublin, which was a publication brought out about 1990 by Claire Sweeney. We've now updated that, and we're bringing that out as well. That should be out. And then Irish Stone Bridges was a book brought out in about 1991 by Peter O'Keefe and Wellington, by part of really the history of what the development of masonry bridges in Ireland and why we've adopted certain standards and all that. And because we had so many masonry bridges in the city, it was out of print. I decided let's go with that as well. So those publications should be coming out now in the next 4 months, just again as part of the social history, because even again as we're doing all these new projects that are coming into the city, you will see in the next few years the development of the docklands and 1 or 2 new bridges down there being rolled out. It is absolutely crucial that we record the importance in the social history that has gone before, and that people have a good reference point, so they do. So I think that's thank you.
Well, I'm sure that you'd agree with me that we've heard a very interesting lecture about an iconic structure in Dublin, and lots and lots of information and lots of slides, and I think Michael did well to get through the slides and select them in a way that wasn't too onerous for the audience. But some of them, I mean, you take one particular issue about the bridge and you could spend a whole evening talking about it. I'm glad that Michael is around to make sure that these books are produced or reprinted in some cases, because they do form an important archive which records the whole history for future generations of the bridges. Now, I'm sure there may be some questions, either general or technical. Sir.
Thank you. My name's John Madden, and I've only been in Ireland since about 2002. But for you, I've come to know Enterprise Ireland, and maybe I've misunderstood it, as an organization that would bring business into Ireland, but it seems that Enterprise Ireland was also a testing company in the past. Is that the case?
Yeah, they actually they had a section which could, in one of the governments, in the merging of departments, Enterprise Ireland actually could carry out, do the testing of quality departments, so they could, and the quality of equipment. And they also provided assistance to other companies as well in setting up standards and checking the quality. But at that time, I'm not too sure whether they still do it, because again, because of the recession we have been through, there again has been reorganizations of various departments. But at that stage, they were doing that, and we had them carry it out. And it made it, again, this was seen as a north-south project as well, which gave it another added part to the bridge, you know. So
I'd like to congratulate Michael on a very interesting talk this evening, and glad that we had some small part in it, in the early analysis. But just had a little bit of humour to the situation. When we were building the Matt Talbot Bridge, which was in the 70s, we had a lot of problems with leaking cofferdams. I noticed you didn't have to deal with that, but I remember going down there and talking to the foreman for several days at a time, and eventually I heard a rumour that they'd managed to stop the water, and I said, what happened? He said, well, we stuffed a donkey jacket in the hole. Now, the corporation probably didn't hear that story, or another one about that bridge. I remember one time we rejected one of the precast post-tension beams, and it was sitting on the quayside, and I remember going down and a couple of days afterwards and said, where is it? And I never got an answer, but I got an unofficial one that had been dropped in Dublin Bay, so that's a little bit of information that perhaps some people don't know. Anyhow, thank you very much, Michael. Very entertaining.
And thank you, because EPO did all the, as you know, all the testing work and strength work, and they produced a first-class report for us prior to us doing the contract.
That was a wonderful address. Thank you. During the course of your talk, you referred to the difficulty of welding cast iron, and you described the method of overcoming that problem by drilling small holes, etc., and going on. I didn't quite see how you could get your cold metal to fill the joint. What did you do with the stuff, how did you get it in, even though you had drilled little holes? Thank you.
The Metalock system is a patented system where you actually put in the stitch from both sides. So in actual fact, you put in a piece and you drive another piece into it to create a tension. It's like a wedge that goes in, and then you go to the other side and you drive another piece in to actually drive it out against. So you actually tie the cast iron together, and when you actually stitch the hole, when you drill the holes, the piece you put into the holes at times, if you drill multiple holes, they're connected. And so when you're driving the wedges, it's like a wedge system really. The whole idea is to actually, not to create tension in the joint that will actually crack it, but it'll actually, merge, tie it all together. And you will drill them at right angles to the crack, and as well as longitudinally along the crack. So you will. So depending on where the crack occurs, you actually they have this this system And there's a glue involved as well, as you can imagine nowadays as well with things. But that is the whole purpose of the thing, to make sure that you fill the crack properly.
Thank you.
So it is. But if you Google Metalocks, they will actually, it'll take you straight into the whole system actually on the, because there is an association in the UK which promotes that system of the usage with cast iron. So it is.
Yes, sir.
Michael, given the destruction in the city 100 years ago, is there any record of damage to the bridge in the events that were celebrated of 100 years ago?
No, the only difficulty that arose in actual fact was, as you may have heard, was when the volunteers, and a number of them were being sent across the Halfpenny Bridge, the guy in the Halfpenny Bridge was asking him for the halfpenny toll. and he, when he had a gun pointed at him, I think he got the message. But that is in actual fact, no, there was no damage whatsoever done at that bridge. I think that it was either up at the forecourts or in O'Connell Street really was the main areas that were hit, you know, because even O'Connell Bridge didn't even take a hit, you know, at the time, so it didn't. But, and yet, as you know from the photographs on our website, from O'Connell Bridge up actually was nearly wiped out at the time, either in the Civil War or in the uprising. We were very fortunate.
Yes, sir.
Hi, Michael. Was it difficult to get a tender process together to rebuild the bridge and to attract competition, and then to agree maybe, it's a very unique bridge, so I can imagine even trying to agree insurances might be very, very difficult in a project like that.
It wasn't that difficult in the sense that when you're in a prestige location, like what I found with contractors was that when it came to building a bridge over the Liffey in the city centre, everybody wanted to be there, you know, because there was just something about it. It was quite prestigious. They perceived it, you know. They weren't just in it for the money, because we found that, say, with the Millennium Bridge particularly, you know, the contractor, the lowest, on that particular bridge, we were told it could be built for $1 million. The lowest tender came in at 2.3 million. So just got the contractor in and said, look, Sunshine, we need this bridge built. What's the way you can build it? So we agreed a price of, say, 1.5 million. Now we had to make some changes, and the designer at the time was a bit concerned. So I asked him, did he want it built or did he not? And so we banged heads together. But nobody made any money on the Millennium Bridge, but it was the fact that they were associated with building a bridge in the city centre. And when it came to the Halfpenny Bridge, yes, we went out to tender, and okay, we got tenders in based on a certain bill of quantities. But once work started, to be fair about it or straight about it, that bill of quantities was sort of expanded, you know, to nearly double its thickness. So when you got the tender in, we had no problem. All the major civils guys tendered for it, you know, but we then had to make a decision on that, but knowing that when it started, and our contingency sum, even though we had built in a contingency sum, didn't cover it either for it.
Yeah, it was a similar question, Michael, that the only person not happy was the paymaster.
Yeah.
In that situation where you know, I'd imagine it was a part to do with timing as well. Had that been now today, you wouldn't get the finance to do this.
Yeah, well, the City Council actually put up all the finance themselves. So I think we may have got a small grant from Intertrade Ireland, which was again north-south, because when the tender, when the subcontractor was from the north, they said, look, we will contribute to it. But there are times when you have to make a decision, and even though the cost is going to go out, you just say, look, in a very short period after this bridge is finished, people will have forgotten what the cost was, because suddenly you have this lovely looking bridge that everybody wants to be associated with it, and it's getting that balance right. And yes, there will be a time when I have to take the flak, both from maybe my chief executive and particularly from the auditors, who will come in and say, excuse me, the tender was so much and you've spent so much, double it, how can you justify this? And okay, the paperwork may be there, but at the end of the day, if the project, you know, and to us, the Halfpenny Bridge was, you know, the jewel in the crown for Dublin, and it needed a major job done on it. And I think that was just a decision we decided we'd run with and go with it. And then after that, make sure you get the opening right around Christmas, and then that gives people a good spirit to actually enter into it. And the other part about it is, and it's coming back to the discussion there as well, is that when you get people involved in a project like that, the contract actually doesn't matter that much, in the sense that everybody's goodwill is involved. They all want to get the right job done. And once you have that, that's 90% of it, because the money issue will resolve itself. So it will. Because the main thing is not to get contractual about it, because if you get contractual about it, then a project like that, it loses an awful lot. So it does.
Are any of the other Irish bridges due for the same kind of refurbishment soon?
No, they're not actually. We carry out tests, the NRA have their sort of annual, is it 3-year, 5-year, and 10-year inspections, and we haven't had any problems at all actually with those bridges. They were all repainted for maybe the year 2000, and the Rory O'Moore one, I'd say, is due a coat of paint now, and that so it is. What we did do was last year as well, we had put in a whole micro lighting system, the green lights under the bridge, and we refurbished for the Millennium, and we refurbished all those last year as well. And we've put LEDs on the butt bridge so that you can see the Dublin colours or Mayo colours or whatever it is actually can be just keyed in on a computer, and they shine up on bridge, so they do. But there is no structural issues at all actually with those. We're very fortunate, and we're sort of fortunate that the rock is close to the surface, because it's really the rock that determines whether abutments move or not move.
Michael was mentioning there about cast iron, and that in itself is fascinating, because when this bridge was built, most of the forges were driven by water wheels, driving in some places very, very large hammers. And I think, as he mentioned, every one of those pieces was made by hand. And maybe it's something, if you were giving this talk again, you might just put in 1 or 2 photographs of some of those old forges to give people an idea of the scale that was in them when they were actually making these bridges and other cast iron implements in those days.
They mightn't walk across the bridge, though. That
Yes, sir.
Michael, thank you very much for a trip down memory lane. As main contractor, Irish Enco, we were delighted to be associated with those days. There was quite a bit of civil engineering involved with the bridge as well, instead of fabrication. A lot of marine work in the river. And one of the things I remember that we did, which was pure simple marine engineering, was we fabricated the temporary bridge alongside Aston Quay.
That's right.
And with the rising tide, we floated the bridge up the river and dropped it in with the dropping tide, and likewise removed it. And one of the other things we elected to do as well was we built a canopy around the construction, so that people of Dublin didn't know what was happening inside. And you were right, actually. I forgot an awful lot about what you're talking about. You brought me back. It was a tremendous amount of detailed work, absolutely detailed. Every component of that bridge was looked at fastidiously and detailed. And towards the end, when we were painting the bridge, got something like 4 coats of paint. There was a lot of carcinogenic vapors coming off, so we had to find a way out of that as well. So we were afraid maybe it was a difficulty. Maybe we were worried that people might kind of inhale the vapors, and we found some way of kind of raising that up into the ethers. But beautiful bridge. I have to say that money does count as well, very much so. And I think it's fair to say that we sorted out our difficulties in the end, if I remember.
Yeah. Oh, yes.
Thank you very much.
We won't mention the song.
Yeah, Michael, let me just ask a question. You said that you had a lot of problems with the nodes, the caps.
Yes.
Just interested to know, were they threaded, or did you actually take them off, or did you just leave them?
I think we had to leave actually most of the nodes actually there, because they had seized onto the end. We had done load testing and tried to actually take a lot of them off, but we were unable to. So what we did was we had to approach it from the other side of the thing, but we were not able to actually take, I think, 90% of them off. Really, it was as bad as that. So it was, everything was seized so badly on it.
Okay.
So
The second question I have, I just asked, the grout that you used to grout in the handrails, just in material type that Aaron described was showing the slide?
Yeah.
Is there a manufacturer's name for that?
Well, Chuckfast was the actual name of the thing, and I think that's the manufacturer's name. So it is. We could.
Okay, that's fine.
Because I hadn't come across that grout before either. It wouldn't have been one of the normal ones that we would have used on a bridge railing, you know. So it would at the time. So it was to do again maybe with the different metals that will allow, because with one of the problems that you have with some of these bridges, and it was a problem with some of the early cast iron bridges, was when you have the sun shining on one side of the bridge, and if you have different metals, they will expand and contract at different rates. So the sockets would be at one thing and the uprights would be at another. And so the sort of infill material joining the two of them together has to be able to cater for both of those.
Thanks very much.
Well, I think it would be appropriate to, as a closing remark, really is to congratulate all the contractors that were involved, all the people that were involved in doing an absolute wonderful job on this iconic structure. And as Michael said just now, you tend to forget all the money that was spent and all the effort that went in, toxic fumes and everything. Congratulations to all the contractors, and also to Michael for being around to make sure it happened and giving us his insights this evening. Thank you, Michael.